Aloha, Richard Halverson here. This is ITS128, and this is the third week of the semester. And let me share my screen. So we are right here, and we had another class this week, you recall, and we actually finished up chapter 2 pretty much. I didn't do a lot of the lab activities, but if you have any problems on any of them, just let me know. You can also take a peek and see if I covered anything like that in here. This is the playlist from last semester. So it looks like I covered labs in here, so you can go check those out if you really need to. But anyway, so today we are, so I don't need to go check the current playlist because I know that I'm at the end of, I know we finished up chapter 2 last time. We did 2.17 last time. So I'm just going to start with chapter 3, see how far we get. And let me, first of all, I want to check. Well, no, I don't need to do that. All right, so chapter 3, types. All right, basic types. So this has to do with the kind of with variables. It's whether variables can store just a whole number, you know, without a decimal point, or can store a number with a decimal point, and also strings, you know, strings of characters like words and sentences, you know, a variable can store those. And so that's what that's what types is about. But we're going to start out by talking about strings, because strings are the most interesting, because, you know, it's a bunch of characters strung together, and you want to be able to index the characters. You want to be able to refer to characters, you know, by where they are in the string and so on. So a string is a sequence of characters. Like this is a string, and it can be stored in a variable. A string literal is the actual string, and it's usually enclosed in either single quotes or double quotes. You've seen all this before already. You're familiar with this. And a string type is a special construct known as a sequence type, because you can sequence through it. It's a collection of objects ordered from left to right. So strings characters are ordered from first letters to the last, and the first letter is 0, the second letter is 1, the third letter is 2, just like you see down here. So if you have like the name Trish, that would be 5 characters. Oh, okay. In this particular example, we have a string, and you can specify a maximum size for a string. That's real important in databases. Not so much in no, I guess you can't specify maximum size. Anyway, so let's say we have a string here that can for some reason contain only 6 characters. They would be numbered 0, 1, 2, 3, 4, 5, and this is how this word would be stored in the string, the 6-character string. It's like that. All right, so the programmer can assign a string just as other types. You know, this is a variable equals hello, or this variable equals whatever this variable is, and so on. And when you use the input function, you're actually asking the user for a string from the keyboard. Even if you're asking the user to type in, you know, what year it is, or you know, how many siblings they have, you're still typing in a string, and your program has to convert that string to a number if that's what you are asking the user to type in. So if you ask the user to type in their age, it's going to come in as characters, and then you use this function called an int function, which takes that string of characters and converts it into whatever number it is that that string represents. So there's a difference between the string, 1, 2, 3, 4, 5, and the number 1, 2, 3, 4, 5, or 12,345, which would be 1, 2, 3, 4, 5, I guess. Okay. All right. So here's an example of using strings. It's kind of a so here what this is you're going to see a lot of these in this textbook. This thing called Mad Libs, and I don't even know how that name comes about. But here you ask the user to type in 4 words, I guess. Okay, so you ask the user to type in well, anyway, you type in 4 words, and the first word is stored there, the second word is stored there, the third word is stored there, the fourth word is stored there, and then this thing just creates a dumb sentence that my, whatever you typed in, says eating, whatever you typed in, will make me more, whatever you typed in. So now I eat them every, whatever you typed in. And so that's just this. So when we run this program, it asks please enter a type of relative, and you would enter brother, and then please enter a type of food, and you enter burritos, and please enter an adjective, and you enter macho, and it asks please enter a time period, and you enter day. And so then it prints out my brother says eating burritos will make me more macho, so I eat them every day. So anyway, indicate which items are string literals. Well, this is a string literal. This is a string literal. This is not a string literal. It's a number. It has to have quotes if it's a string literal. They all have to have quotes. This is string. This is, and this is. So they all are except this one. Which answer creates the, let me just confirm this. Yes, no. Okay. Which answer creates a string variable with a value of this? So this is a variable, so that's going to be on the left, and then there's an equal sign, and then there's something on the right. And so this is the variable name, so it's going to be on the left, and then your string variable that has a value. So it's going to store this value, this value into this variable. So it would be this one. This is the variable, and this is the string. You have to say it's a string. This would be, this would presume that there's a variable named Daniel, and there's not. So this would cause an error. And this is, of course, wrong. So it'd be this one. Which answer prints the value of first name? Well, it's this one. This one actually prints, first name is, this one prints the variable name. This prints the variable name. This prints the variable name. This prints the variable value, the value of the variable. Okay, so the input, this input is actually what's called a function, and it when you execute it and it's done executing, it's going to have something. It's going to have a string, and so that string is going to get stored into first name. And what the input does is it displays that out on the screen, and it sits there and waits for you to type something in until you type the enter key, and that's the end of the string. And then this thing is done, and it hands you back what the user typed in, and that gets stored in first name. So This is the answer to that. All right, so string length and indexing, this is pretty important. I mean, you're going to really use indexing a lot in Python. In fact, Python's the best language for string manipulation, I believe. Okay, first of all, there's this function called len, which will return the length of the string. So let's say you have so this is actually an assignment statement that assigns this variable, George V. It assigns it all of this. And this is how you continue on to the next line. Okay, so this is actually the same as having this all in the same line as this one and this one and this one and this one. The trouble is it would be so long that it's too long, or it would wrap around and it would be, it'd be difficult to understand. So Python lets you do this, where you can concatenate sort of. Anyway, so that this is an assignment statement that assigns this big long string to this variable. This variable is assigned this string, and this variable is assigned this string. And so this is going to print out the length. This is going to print out the length of this variable, which is pretty big, see? And this is going to print out the length, and this is going to print out the length. So we see the length here. So that's the length function. Okay, so you can index characters. Okay, this is a string, but you can index, or you can sort of get at or reference characters of the string by the index of the character. So this is the 0th character, which is A. This is the 1st character of the first character. This is B, and this is the 25th character, which is, I guess, Z. Because 26 characters, 26 letters in the alphabet, starting with the letter 0, starting with the 0th letter all the way up to the 25th letter. So you see, this is what displays out the Z, because it's the 25th. It's index 25. It's the 26th letter, index 25. All right. Oh, and you can also do it this way. So you can do it alphabet -1, and minus means you start at the right and you go in. So -1, -2, -3. So that's another way of referencing a character in a string. So this is okay, yeah. So this is something that prints out the actual index. You enter in an index. So 2 runs, and this prints out the index 2, which is C. But let's see what happens when we do -2. Yeah, see, it does Y, because Y is -5 is 1, 2, 3, 4, 5. It'd be V. So anyway, okay, all right. Expression, my country. An expression is not an assignment statement. It's something that could go on the right side of an assignment statement. But anyway, the first character, I presume they mean the 0th character. Changing string variables and concatenating strings. All right, so let's say you got 2. Doesn't let us do this. Cannot change a character. Individual characters of a string cannot be changed directly. Okay, so it's not like a list. You treat it like a list. You reference it. You reference characters like list elements, but you can't do this. You actually have to do splitting and concatenating and that kind of stuff. We'll see how it works. All right, so right. So this is just saying you have to, the left side of the assignment statement cannot be where you're indexing the character of a string. Okay, that it doesn't let you do that. This is you're indexing the 0th character, and here you're indexing the 1th character, the 2nd character, and you can't do that. Okay, so anyway, we'll see how you do that instead. Okay, this is string concatenation, where if you have a string and you use a plus sign, normally a plus sign is for addition when you're dealing with numbers, but when you use a plus sign and the operands are strings, then you are concatenating. You're putting you're sticking this onto the end of this, and so you end up with New York like this with no space in between. If you wanted a space in between, you have to stick a space in there. So here we have this example where we have string 1 is this, string 2 is this, and the concatenated string is we're just concatenating them together, and then when we print them out, it's easy as whatever that is. It's the concatenated string. All right, executing said you can't do this. So no, this is not a valid way to do it. False. In-place modification of string variables is not allowed. All right, it's 347. Okay, let's do one of these challenge activities. Let's start. Print. Gee, this is so challenging. TIFA, enter. CID, enter. Anyway, you can do this. It's just CID again. So we start out by assigning person equal to this string, but then we write over it right away with this string, and then when we print it out, it's just going to be this string. All right, what's this challenge activity? Reading multiple data types. Do not write a prompt for input values. It wants you just to do this with no prompt in between the parentheses. All right, type 2 statements. The first reads the user input into person name. Reads the user input into person name, okay. Person name equals input, okay. Second reads the user input into person age. Use int. Use the int function to convert person age to an integer. So I do person age, personage, person age, and this would just give me the person's age as characters. And if you use a plus sign with characters, you're concatenating. But we want to use see, we're testing here. We want to we want to read in those character digits and actually treat it as a number. So to do that, we're going to take what we read in and convert it into an integer. So we put this int around it. So first it reads it in, and then it then makes it an integer, and then it stores it in there. So this looks like this is probably the answer. So, okay, so it's just going to test it. We don't type in any data. So anyway, that's that. Concatenating strings. Okay, so what we want to do is write two statements to read in the values for my city and my state. Assign log entry with current time, my city and my state. Values should be separated by space, sample output for given program if my city is Houston. Okay, so basically you start with this, and then you ask the user to enter a city, and it concatenates that onto the end of this, and then you ask the user for a state, and it concatenates the state. It puts spaces there. What are we supposed to do? We're supposed to. Oh, okay. So we have a variable. Okay, so first we have to read in a city. My city equals. I guess they like to put equals input. Ask the user for a city. Ask the user for a state. It's characters, so I can just leave them this way. Do not provide a prompt. Assign log entry is equal to current time plus a space plus the city, my city, plus a space plus my state. So let's see what happens when I don't put these here, because that's probably what you would do. You'd probably do it this way. And you go like that, and it would go, boom. This is what your output was, and this is what your output is supposed to be. So you're missing a space here, and you're missing a space here. Yeah, so that's basically what happens if I just do this. Ooh, that's cool. So now it should work. All right, there we go. Oh, okay. All right. Okay, so those were strings, and now this is a new kind of thing called a list. It's similar to a string, but not really. You can have a list of strings. So a container is a construct used to group related values together and contains references to other objects instead of data. A list is a container created by surrounding a sequence of variables or literals with brackets. All right, anyway, so brackets. Okay, so you can define a list like this. You got a list called my list, and you got two things here. You got a 10 and you got an ABC string, and you want to make it a list. So you just put brackets around it and separate the elements of the list with a comma, and there you have it. Each list item is called a comma. Each list item is called an element. All right, a list is a sequence. It's a sequence, means it's ordered. And you can refer to elements in the list by their index, starting with 0. And so, and if you just have this as an assignment statement, where you're assigning the variable mylist equal to this, what you're doing is you're assigning it, you're basically declaring it as a list, and it's empty. So my list is now a list, and so all the kinds of operations that you would do on a list, you could do to my list. And so you cannot do operations on my list that you would do on a variable on a variable that's an integer, for example. So like you wouldn't multiply it by 2 or anything. Anyway, so that's how you declare a new list and you set it equal to 0, basically. And so here's an animation of how this works. You should click through it. This declares it, and then here, let's just see what it does. That's going to declare. This is the Python interpreter takes this and it creates a new place called prices, and it it pops these things in, so it ends up taking 4 spaces, I guess. Yeah, I guess there's going to be a space for the name of it. Price holds references to objects in the list. Okay. This is what that is. Okay. So anyway, so I got the points. The following program prints a list of names. Try adding your name to the list and run the program again. Okay, run. See, what's nice about Python is that, you know, if you just want to print something, if you just want to print a variable, and it can be any kind, it can be a dictionary, it can be an integer, it can be a string, it can be a list. In other languages, you would have to like know how know what the variable is, and then for like printing a list, you'd have to you know, do a loop and index through each of the elements of the list and print those out. But in Python, you can just say print names, and it'll just print them. It might not print them in the format that you want, but it's going to print it like how it is, how you should represent it. You know, a list with brackets. And what happens if I do this? Okay, so it does put the 5 there. So it's this is a number. This is a you know, a string. All right. Anyway, so you should put your name in this. Write a statement that creates a list calling mynums called mynums containing these elements. Well, you know. All right. Accessing list elements. So let's say you have okay, let's say you have some variables here, and let's say you have this variable here, and this is what the value of the variable is. Was this the price of a car or something? The price of a Lamborghini. And so it's that amount, and this is a Bugatti, how much that cost, and then this is another one, and that's how much that cost, I guess. And now we want to make a list called prices that contains the Lamborghini price first, and the Bugatti price second, and the Aston Martin price third. And so that's fine. So this is going to be the price of the Lamborghini, because it's 0, it's the 0th element. This is going to be the next element, and this is going to be the last element. That's all. So that's how you access, or that's how you can reference element lists. Oh, look, here's a challenge. What are we supposed to do? Initialize the short list of names with these. And so it does this. I'm going to do this, copy, paste, and I'm going to get rid of this. And I'm going to put a brackety thing here, and a brackety thing here. And I'm going to see if this is right. Yeah, it is. Fantastic. Okay, updating list elements. Well, with list elements, you can update an element one element at a time. I gotta figure out where that beepings come from. I think it's like turn off the alerts, turn off the sound of the alerts, and I still get these things still beeps. If anybody knows how to turn off those beeps, let me know. All right, so here's an example of you create a list and you print it out, and that's what it looks like. And then you decide you want to change the middle element, not the 0th element, not the 2th element, but the 1th element, the second element here. And you want to make it -28. Well, you can just do an assignment statement like that. So that works. And now you print out the list, and lo and behold, that middle one is changed. So you can write a statement that assigns myvar with the 3rd element of my list. So, you know, myvar equals my list 3rd element. It must mean that one. Say, can you hold on 1 second? I gotta go check something. So that's how you can reference an element in a list. All right, so adding and removing elements. Okay, so really to add an element onto the end of the list, you should use this append method. So you have the list name and you say dot append and then the value in parentheses, and that just, so this, for example, would add this string onto the end of this list. So that's how you append onto the end. This is how you can remove an element from somewhere in the list, from any index. You can just pop it out and the list gets one smaller. When you do this, okay, it doesn't return the value, I guess. Okay, so yeah, so that's what that does, and then this one removes the first element in the list that has this value. So it'll start the beginning of the list and go down, and when the first one it finds of this value, it'll remove that in the list, and the list will get smaller by 1. So this is you got a list like this, and you and this prints it out, and then you're going to append an ABC onto it, and then it's going to be 10 BW ABC, and then you pop off the BW, and then, well, let's just do it. So this is the list 10 BW ABC, and then you're going to pop off the BWC, gets smaller, and now the list just looks like that. And then you're going to remove the ABC, and then the list is just going to have 10 in it. All right. Update the price of the second item in house prices to this. So you're going to say house prices bracket the second one, which is 1, I guess, equals. Now these are strings. These aren't numbers. These are strings. So it should be this whole string definition like that. It's a string, not a number. Okay, sequence type methods and functions. Okay, so these are some functions and methods that are useful to lists. You can just say there's the length function, and this is not, it's not period. It's just length, and you put the list inside there, or the name of the list there. This returns the number of elements in the list. This will concatenate the first list, or will concatenate the second list onto the first list, just like strings. This will find the list with the smallest value. Oh, okay, all the elements have to be the same type. This finds the list with the largest value. They all have to be the same type. This adds up all the elements of the list. They have to be numbers. This will find the value, find the index of the first element in the list whose value matches this. So this whole thing here will return a number. It'll return a number, and the number will be the index of that element, the element has that value. And if there's more than one, it'll be the index of the first one. And if it's not in there, I presume it returns a -1, probably returns a -1. This will return the count of occurrences of this value. So if there's 5 ABCs in there, this will return this is 5. So this is a list, and this is a list. And when it's done, it's just going to be 4 in the list. 4 in the list. And the cheapest house is min house prices. And the most expensive one is max. Okay, now keep in mind, these are different than these. Okay, these are different. You know, these functions, min and max, will work on numbers. These are numbers. See, there's no quotes. Min and max will not work on these. All right. The following program calculates some information regarding final and midterm scores. Try enhancing the program by calculating the average midterm and final scores. Okay. Okay, so, oh, I see. Okay, so we have a couple of lists here. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 4, 5, 6, 7. Either more scores, more midterm scores and final scores. All scores, we're going to concatenate. All right, that's fine. We're going to, the number of midterm scores, the number of final scores, that's fine. Print the number of midterm scores, print the number of final scores. Then calculate the number of students that dropped. And then what's the lowest final and what's the highest final? And we're supposed to calculate the average midterm and average final scores. Okay, well, anyway, let's see what this one looks like. Oh, are we supposed to? No, there's no data. So it just runs and it says this. 90. Okay, so we do something like, is there a sum? Let's see. Does this check my work? Okay, I'm going to say average midterm equals, did they say there was a sum function? Ah, there's a sum. Okay, equals the sum of midterm scores. There's a midterm scores, right? Midterm scores, sum of midterm scores scores. Divided by average. Is there an average function? Is there an average list function? Python list average function. Find the average. Oh, well, we just length mean. Anyway, sum and length is what I'll use. Sum and length. So it equals a sum divided by the length of midterm scores. So I can say, and final, average final is, there's no way to, final, print, average, midterm, and final scores. I don't know. Now this is probably going to look kind of funny because it's going to have repeating decimals and so on, but let's just see what this looks like. That's the average midterm, that's the average final, and I should format it using brackets. Not this one. Well, anyway, you can fiddle with it. Okay, just use the min parentheses total function. That's pretty easy. All right, let's do this. What time is it? What is the value of the length of age 1, 2, 3, 4, 5? Okay, that's pretty easy. You can do those. Tuple basics. Okay, now there's another kind of variable type. It's called a tuple. A tuple, a tuple, tuple. I say tuple. You can call it. Some people say tuple. It behaves similar to a list, but it is immutable. That just means that once you make the list, or once you make the tuple, you can't change the tuple. You have to make a new one out of the old one. A list, you can change the list. You can just say, this list is fine, but I want to change the third element. You can just go ahead and do that. But if you have a tuple and you say, I want to change the third element, well, you got to make a new tuple. You got to take the old tuple, take the first for the third element, and then you got to put the new third element, and then you got to take what's the rest of the third. Yeah. So it's like strings and characters. Typically, tuples are surrounded in parentheses. Note that printing a tuple always displays surrounding parentheses. It's not as common as a list, but it can be useful when a programmer wants to make sure values do not change. So here we're going to define a tuple. It's got it's a tuple. Yes, it's a TW. It's actually a, and you reference the elements in the same manner. It's got order. There's order to it. So that's a tuple. This is really easy. Parenthesis. It's these. Copy. Parentheses. Paste parentheses. Get rid of this. Right. Okay. Named tuples. A program commonly captures collections of data. For example, a named tuple allows the programmer to define a new simple data type that consists of named attributes. So a car named tuple with fields like this, or it's a tuple that is named car, and it's got a price field and a horsepower field, could more easily present the car would more easily represent the car object than a list of index positions. Makes sense. Okay, so we have something like I guess we have to import a module to be able to use this feature of Python. So it's kind of not built in, not really built in, but so you can so you have a car and you want it to be a tuple, and so you can define it this way, where where you have the name, and then you have, it's like a list defined inside. So you can do it this way. Wait a minute. No, you these are the field. These are the names of the fields. So of the, you can call them fields, items. So you're going to have a tuple called, a named tuple called car, and car is going to have 1, 2, 3, 4, 5 fields or attributes, and their name. One is going to be called the make, then there's the model, then there's the price, the horsepower, and the seats. And so this is how you would use this tuple type. This is a type now. It's a car type. And so here you're going to create an instance of the car type. You're going to create an instance, and you're going to call it Chevy Blazer. So Chevy Blazer is, what type is it? It's not an integer. It's not a string. It's a car type. And this car type has 5 attributes. And the first one, the make, is going to have this value. The model is going to have this value. The price will have this value, and the horsepower this, and the seats this. And so when you print it, it's going to print out like this. So anyway, interesting. I've never used tuples, or I've never used named tuples. Create a new named tuple dog that has the attributes name, breed, and color. So dog. Okay, so dog equals named tuple. Yes, named tuple dog, comma, left, right, left, left, quote, name, breed, color. Am I doing this right? Let's see. I need to have, yeah, they're in quotes, brackets, comma, comma, and okay. Yes. All right. I know what I'm doing. Oh, I should have just looked down here. Create a new address object using house, where house street is this, city is this, and country is this. So that looks more like this. So you say house equals address of this, and is that right? Yes. And this, and this. All right, very good. Okay, you can do that one. What's this? Define a name tuple called player that describes an athlete on a sports team. Concludes name, number, position, and team. So it's going to be something like named tuple. Let's see, some car. No. Player. Yes. Player, comma, left bracket, number, so name first, number, and position. Oh, and team. Close. Cam Newton, one quarterback, Carolina Panthers. Okay. All right. Is that it? All right. It works. Okay. Sets. A set is an unordered tuple. List strings, lists, tuples, sets. Okay. Right. A set is an unordered collection of unique elements. So it's unordered. Elements are unordered. Elements in the set do not have a position or index. Elements are unique. No elements in the set share the same value. Okay, so that's two things. No order and no duplicates. Okay, a set can be created using the set function. It's the notation is similar to it's kind of similar to a dictionary. Oh, we haven't gotten to dictionaries yet, but we will next time. A set can be created using a set function, which accepts a sequence type literal iterable object. The tuple, okay, a list. Okay, it accepts a sequence type iterable object whose elements are inserted into the set. A set literal can be written using curly braces with commas separating the elements. Okay, so create a set using the set. So okay, so this is This is you can create it using this function, or you can create it using this function. Okay, so this creates a set called nums. It's got 3 elements in it. It's got a 1 and a 2 and a 3. And here's another way to create another one. You can use curly braces. Note that an empty set can only be created using this. Okay, the reason is because if you create an empty set using curly braces, then that's how you create a dictionary. So it thinks you want to create a dictionary instead of a set. A dictionary is a completely different thing. Okay, so here we have creating sets. How far does this go? Okay, so yeah, right. Yeah, so you have a list of names, and look, there's three Rons in there. But then when you create a set of this list, yeah, so this is a list. So when you create a set of the list, it's going to turn it into a set, which means it's just going to remove duplicates. So what's the result of the set? I guess it'd be 100, 200, 300. Okay, so to modify a set, there's an add method. So this will put it in there. To remove a set, to remove a value, there's a remove method. You don't have to worry about the first one, because there's only going to be one. There's going to be 0 or 1 of them. And pop removes a random element from the set. So it pops any element off the set. Here you specify something you want to remove. This will just give you an element and remove it. The set becomes one smaller. So if you want to just traverse through the set, remember there's no order, so this works. This method clears all of the elements out of the set. The set will be 0 after this is done. This adds a set to a set. This gives you the number of elements in the set. This adds a value to a set. This adds a set to a set. So you use these methods to modify a set. All right, let's do let's do a challenge activity here, and then maybe we can end. And I might come back to this next time. All right, so the top 3 most popular male names of 2017 are these, according to this website. Write a program that modifies the male names set by removing a name and adding a different name. What? Oh, I see. All right, so add a name and remove a name. Okay, so what we want to do is first we want to add a name. So male names dot add. Which do we do first? It matters. Well, first it removes, then it adds. Okay. Male names, remove, parentheses, name to remove. And then we're going to add male names, add name to add. All right, let's see what this does. Pretty dumb. So here's some other set operations. Why don't you look through these, but here, this will return the intersection of a bunch of sets. This will return the union of a bunch of sets. This will return the difference. It returns a set containing only elements of the set that are not found in any of the provided sets. So, so it'll return the elements of this set that are not in any of these sets. Difference will remove all of these elements from this set. So if they're not in there, if they're already not in there, but if they are in there, it takes them out. So what's left is any element that was in here originally that is not in any of these sets. So that's difference. And then symmetric difference returns a set containing only elements that appear in exactly one of the two sets. So that's interesting. Okay, because this is not symmetric. This set A minus set B is different than set B minus set A, but in this case it's the same. All right, so anyway, you can look through these and do these exercises, participation in challenge activities. If anybody has a problem with this challenge activities, let me know and I can go over it sometime, next time maybe. So next week, I'm very busy Monday, Tuesday, and Wednesday. So we'll have one class next week, probably Thursday, maybe Friday. Are there any questions? So we pretty much finished sections 3.1, 2, 3, and 4. I will thank you. I will see you on next week. Oh, yeah, okay. All right. Thanks for watching.